In this video, we're going to be looking at combinations, which is from our textbook, chapter 15, section 7. And the two big things that we need to know for combinations is that order does not matter and that it is without replacement. So if you printed out your notes packet, we are on page 6. And I'm just going to write that at the top and highlight that order does not matter and that this is without replacement. So if you think of the way that I started the permutations video with the 3 stuffed animals, those were lineups. And so now I would ask you is if I have a duck, that little kitty cat Figment, and a lamb named Olaf, if I was just going to take them all with me, there's only one way that I could take all 3. So we're going to do a warm-up here with fruit. So for letter A, I had 4 pieces of fruit to choose from this morning, and I wanted to bring 2 in my lunch. How many different combinations could I make? So let's do an apple, a banana, let's do cantaloupe, and let's do grapes. Okay, so, and I'm not going to list out all the names, but apple, banana, cantaloupe, and grapes. And if you're just choosing 2 at a time, you could do the apple and banana. You could do the apple and the cantaloupe. You could do the apples and the grapes. You could also do, and that would be all of your possibilities with having apple as an option. We already did banana, apple, so now I could do banana, cantaloupe, banana, grape. And then finally, the last one that I could do is cantaloupe and green. So there are 6 ways. Okay, well, what if I decided to bring 3 pieces of fruit? Well, we could have the apple, banana, and cantaloupe. I could have the apple, banana, and grapes. I could have the apple, cantaloupe, and grapes. And then finally, the banana, cantaloupe, and grapes. So there are only 4 ways. Okay, and letter C, I'm going to say, what if we wanted to bring all 4 pieces? Well, guess what? How many combinations could you make just one way? A, B, C, G. So one way. Okay, well, what would that look like using a formula? So we're using a combination formula here, and it's called NCR, and we're going to have 4 total options, and we're going to choose in letter A 2 of them. And what that means, it would be 4 factorial, and then in this formula you divide by n and then the difference of n and r. So sorry, you divide by n factorial and then r factorial and n minus r factorial. So this pertains to this one here. So then that would look like 4 times 3 times 2, all divided by 2 times 1 times 2 times 1. So I would say that the 4 cancels with the 2 2's, and then you would just get your 6 ways. Here you have a total of 4 elements, and you're choosing 3 at a time. So you would have 4 factorial, r is 3, so 3 factorial, and then 4 minus 3 is 1 factorial. So it'd be 4 times 3 times 2 times 1 divided by 3 times 2 times 1. Whenever you're 1 different, it just ends up being n. So if these are off by 1, it's just n. And then this way would be 4 CR, 4 choose 4. And then here you would have 4 factorial over 4 factorial, 0 factorial. So that's always going to come out to 1. So this is our formula here. There are 2 ways that we could use that. So here is NCR, and then here is N and R. So these are 2 different notations meaning the same thing. So they're both for combinations. And what would that look like? So we're going to do 1 and 2 here at the bottom. So for number 1, I would have 5, choose 2, 5 CR, 5 C2. So I would do 5 factorial, and then I would divide by 2 factorial, and then the 3 minus 2 factorial. So then that would be 5 factorial divided by 2 factorial, 3 factorial. And we could certainly do that by hand. So I'm going to show you one last time how I can do that by hand. So 5 times 3 times 2 times 1 over 2 times 1 times 3 times 2 times 1. So what I would always do is cancel those pieces out, and you're going to get 5 times 2 is 20. Actually, I would even keep canceling. So the 5 divided by 2 is 2, and you're going to get 10. My question to you is this any different than 5, choose 3, 5C3? And if you look, it's not, because then you would do 3 factorial, and then 5 minus 3 will give you the 2 factorial. So these are the same, they are equal, and you can see the notation this way or that way. So the question is there a better way to do these? And of course there is, so you can use your calculator for this. So I'm going to turn my calculator on, and then just like we did with the permutations, you have to put the 5 in first. So I'm going to enter in 5, and this is exactly where the permutations formula is. So now I'm going to go into the math menu. I'm going to scroll to the left into probability, and I'm going to go down to number 3, NCR. I'm going to hit enter, and now I'm going to type in 2, and it will give me the 10. Okay, so let's go ahead and try that for number 2, the 9C4, so 9 choose 4. So I'm going to have 9, math, probability. I'm going to go down to number 3, NCR. I'm going to hit enter. I'm going to type in 4, and I get 126. So the math would have been a little bit harder to calculate on that one. Okay, so now what we're going to do is we're going to flip to the top of page 7. And the questions here are saying, are the following a permutation or a combination? So if it's a permutation, order matters and it's a lineup. If it's a combination, it's just grabbing things and it doesn't make any difference if it's a lineup or not. So if you'd like to pause the video and try A, B, C, and D on your own first, go for it. Otherwise, I'm going to go ahead right now and try those. So letter A, if 9 books are placed in a row on a shelf, well, that's going to be a lineup. Anytime you have that word shelf and you're placing books on a shelf, that will always be a permutation. That will always be a lineup. Okay, letter B, 3 books are selected from a collection of 20 books. So you're just taking the books, no particular order. You're just grabbing the books, putting them in a bag, or just putting them in your arms. So that's just a combination. Letter C, an arrangement of the letters in the word book. Well, we did some of those with the repeating letters. So anytime it's an arrangement, that's going to be a permutation. Okay, and then finally, a locker combination. Well, the word combination is in the example. So does that mean it has to be a combination? It's actually a misnomer. So if your locker combinations say were 12, 30, and then 19, this is an arrangement of a particular order. So it's a misnomer. It's actually a permutation. Now, if you go back to school someday in our future and you go to school and you say, oh, I can't remember my locker permutation, your friends are probably going to think you're a little crazy. So I wouldn't use that language, but it is a permutation, not a combination. All right, number 6. How many 5-player teams can be formed from 8 people? So the N that we were talking about in our formula is the total. So N equals the total. And then R is how many we want. How many 5-player teams can be formed from 8 people? And then always ask yourself, is there a particular order that is happening here? And in this case, there isn't. So you can do 8, choose 5. You could also write it as 8, choose 5. So these are synonymous. And then you would go right to your calculator. And we're going to do 8. It takes a little while to get used to putting in the number first. And then math, you can go over to probability, down to NCR, and I wanted 5 members of the team, and I'm going to get 56 possibilities. Okay, Now we're going to go over to the bottom, and I know I'm skipping some examples. That's for the sake of time, and we're going to go over some of these in office hours. So this chart here at the bottom is talking about a deck of cards. So this is a deck of playing cards. Some people are familiar with them, some are not. Diamonds are red, hearts are red, spades are black, clubs are black. And I'm going to write those words out again. So red are diamonds, spades are black, clubs are black, and then hearts are red. Okay? And then an ace does not have a face. However, a jack, a queen, and a king do. So these are your face cards in each suit. So there are 3, 6, 9, 12 face cards in a deck. Each suit has 13 cards. So it's almost like the ace could be 1. In some games, the ace is high. In some games, ace is low. But you have 1 through 10 and then another 3. So 13 cards in each suit. Okay, and then there are 4 suits. So there are 52 cards in a deck. We've been playing some Rummikub online, and that's a good way that you can play this. We've also been playing Hearts online. So if you have some spare time, you can play some of those games with friends, and I'll help you get acquainted with kind of how this all works. All right, so now I'm going to go over to page 7, page 8. Going over to page 8, and we're going to do 11 through 14. I have played a lot of cards, so I'm very comfortable with a standard deck of cards. It might benefit you to play some cards if you have some free time and you happen to have them at home. Number 11, a standard deck of cards consists of 4 suits, clubs, diamonds, hearts, and spades of 13 cards each. How many hands of 5 cards can be dealt? All right, well, this is saying that there are 52 cards in a standard deck. So that's going to equal N, our total. And I don't care about a particular lineup. I just want to have 5 cards. So therefore, R is 5. So we're going to do 52, choose 5. They like these card questions. And I'm going to go back and forth between the notations so you're comfortable with both. So 52, going to probability, choose 5. And I get this huge number. So this is 2,598,960. It's a really big number. And we're going to be using that number down the road in some other questions on probability in a couple of weeks. Okay, number 12. In a standard deck of cards, how many hands of 5 cards all can be made from the same suit? Okay, or how many hands of 5 cards all from the same suit can be dealt? So the key here is same suit. Same suit. All right, so I want each suit, remember, had 13 cards. So let's pretend we were looking at hearts first. So if we were doing hearts, you would have 13 total cards, and out of those 13, you'd be selecting 5. Okay, it's red. It's a red heart, not a black heart, just so you know. All right, and then there are 39 cards that are not hearts. And out of those 39, you want none of them. You want none of the 39. Now, go ahead and do 39, choose 0. And if you think about the formula, 0 factorial is 1, and then your denominator would be 39 factorial. So this is just 1. So this is 1. And now we're going to do 13, choose 5. And I get 1,287. So when we do 1,287 times 1, I get 1,287. It does not specify the suit. And this is where these questions get really, really tricky. So I couldn't even read the question, but it's always asking for something very particular, and well-worded questions kind of tell you what you're looking for. So this could have been hearts, diamonds, spades, or clubs. Okay, so there are 4 different suits, and they just want all of one. So we're actually going to multiply that by 4. So now I'm going to take the 1,287. I never cleared my calculator, so I'm just going to do times 4, and I get my final answer of 5,148. So this is one saying that any suit you could have, whereas number 13 specifies. Given a standard deck of cards, how many 5-card hands can be dealt that include 4 hearts and 1 from another suit? So this one is telling you exactly how many hearts you want and how many hearts, how many non-hearts you want. So there are 13 hearts in a deck, and we're going to select 4 of them. There are 39 that are not hearts. So these are not hearts in the deck. These are the hearts. So I have 13 hearts and I have 39 that are not hearts. Out of the 39 that are not hearts, I want 1 of them. So it would be great if you could recognize that 39, choose 1 is 39. It would save you a little bit of time. Otherwise, you can just do 13, choose 4, times 39, choose 1. I just feel like that's kind of tricky to do. So if you do that all out, and you can kind of see I have the 13, choose, or C, 4 times 39, C, you can't actually see that number 1, and I get 27,885. But watch, if I had just done 13, choose the 4, I would get my 715. And then if you just know that that's times 39, you get your final answer. Okay, so that's just another way to think of it. All right, we're going to do one final question together right now. So I have given a standard deck of cards. How many 5-card hands can be dealt that include 4 of one suit and 1 from another? So here, it's almost the exact same question as number 13, except in 13 it specified hearts. In 14, it's saying how many ways can that happen. So I'm just going to write this a different way. So you would have 13 choose 4 times, so 13 of one suit, you want 4 of them, 39 not of that suit, and you want 1 of them. But there are 4 ways that that can happen. So we're really just taking this number here, the 27,885, and multiplying it by all 4 suits. So the hearts, the diamonds, the spades, and the clubs. And then you can just do, if you don't clear a calculator, you can just do times 4, and you get 111,540 ways that this hand could be dealt. So if you like poker, you're kind of counting out different ways, and we will get to probability with those types of questions. So this is an introduction on how to use combinations. Remember, if it's a combination, the order does not matter, and it is always without replacement. Thanks for watching.